Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FIRDAUS bin FATHILATul ZAKIMI, and for my part, I will explain question 1 and question 2. So we are given this question. So for my part, I assume k is equal to 4, a is equal to -10, b is equal to -15, c is equal to 17, d is equal to 2, and e is equal to 10. So all of this we put into this question, and I got this question, and I got this as result. After that, we need to determine the transfer function of the system. Hence, we need to change the value of s to replace the value of s to j omega. So I got this as the result. So I need to put the frequency transfer function in standard form. So this is the value of the frequency transfer function in standard form. Next, I need to separate the transfer function for log amplitude plot and phase plot. So this is the log amplitude plot, and this is the phase plot. Next, I use Scilab and word plot technique to obtain phase margin, gain crossover frequency, gain margin, and phase crossover frequency. So this is the result from the Scilab. I get phase margin 70.94 degree, gain crossover frequency 0.465 Hz, gain margin 5.308 dB, phase crossover frequency 1.003 Hz. So the value of this, I also can convert the value of Hz to radian. And for this is the original code for the plot, and this is the value of this. This is the value I take for my gain. Next, we also can know the gain margin, gain crossover frequency, phase margin, and phase crossover frequency from the plot. That's all for my part. Thank you.
Assalamualaikum, and Miss AMZAR. Okay, for my part, I will explain about the LED compensator 10%. For the question, is use both LED compensator to further improve 10% of current phase margin of the response. Show the final transfer function of the compensator and its phase and amplitude response. Okay, first, from the original phase margin, we have to find 10% from the value. Okay, we get 7.094. Then we add the original phase margin with the 10% of the original phase margin. After we add, we get 78.034 degrees, and then after that we find phi max. Phi max is equal to PM phase margin ni is equal to phase margin required minus phase margin current plus 15. 15 is a safety margin for the LED compensator. Okay, for the value is after we substitute the value, the phase margin required is 78.034 0.034 minus PM phase margin current 70.94 plus 15, then we get 22.094 for the Fimax. Okay, then for next step, Fimax sine -1 alpha negative alpha -1 over alpha +1. Then just substitute the Fimax. Just substitute the Fimax that we get from the PM phase margin need. It's 22.094 from above. Then we just solve the equation like before. Then we get 0. We get 2.205 here. For the omega m, so go to GCF. We just find the omega m, which means 1 over tau. 1 over tau square root alpha. For the omega m, just for the omega m, we just take a value 2.90 equal to 1 over tau square root 2.205. Then we get, after solve equation, we get tau. The tau is 0.075. Okay, for the GCS, the equation is 1 plus alpha tau s over 1 plus tau s. Then we get 1 plus 0.165 seconds over 1 plus 0.05 seconds. So you can see the bot plot compensator. There is the coding. So you can see we just substitute our value here, K A B C D E. Then this one is GC. Okay, for the phase margin after phase this is phase margin we get from the Scilab. This is 61.718, and the gain crossover frequency we get 0.522. Then figure 3 and figure 3.1 shows the phase margin and the gain course phase margin 61.798, and again crossover frequency 522 after the transfer function has been added with the lag compensators. Lag compensator transfer function is taken from the calculation in figure 3. Okay, the lag compensator I will give to my friends. That's all. Thank you.
Hello, my name is ALIF bin ROSLI, and I will explain about land compensator. Okay, for question number 4, the land compensator is to further improve 10% of current phase margin of the response. Okay, this is the PM of after 10%, which which we get 88.034 degree. Okay. The frequency phase is 0.893 dB, and then we get alpha 1.108, and tau we get 4.016. This is the calculation for our lag compensator. Then this is the coding to find the compensator, and here is the bot plot. This is the magnitude and then phase and something like this. Okay. And this is the PM GCF of lag capacitor from Scilab. Figure from 4.1, 4.2 and 4.3 show the phase margin and gain crossover frequency after the transfer function has been added with lag capacitor, and the lag capacitor transfer function is taken from the calculation in figure 4. And now we move to question number 5. Uh, it's on based on the finding in question 3 and 4, which capacitor that can be used to achieve 10% improvement of phase margin. Okay. We can conclude that the lag capacitor is better suited for meeting the desired phase margin requirement after obtaining the achieved phase margin for both lead and lag capacitor. The phase margin deviation for the lead capacitor is 78.034 minus 61.718, which gives 16.316, while the phase margin deviation for the lag capacitor is 78.034 minus 61.206, which gives the result 16.825. That's all for me. Thank you.